Alright, welcome to Emilak Online Tutorial. Now before us today, we'll be looking at how to solve this equation using the Lambert W function. Alright, but first of all, we need to understand what Lambert W function is. Okay, now let's take for example, we have e to the power of x equals, let us say, 2. Okay, now for us to find the value of x here, what we just need to do is let us apply the ln, which is the natural log, to both sides. Okay, now looking at this now, you get to see that ln, okay, now we undo e here, leaving us with x equals what? ln 2. Okay, all right, so this procedure or this principle, okay, is the same principle the Lambert W function does. Okay, and how does it apply? Okay, by the formula you have it that W function, when applied to a rule like, let's say, a exponent of a. Now when an argument is given like this and W function is applied to it, it gives us a. Okay, so what the W function does is to undo the product of a with its exponential expression. Okay, all right, now this is just the basic rule which means whenever we have equations like this, or equations that cannot be factorized, okay, all right, or I'm sorry, exponential equation that cannot be undone with algebra, then we get to use what? The Lambert W function. Okay, and our goal in this equation now, exponential equation, is to resolve it to becoming something like this. Okay, so how then do we do this? All right, now first of all, let's divide the equation by x. Okay, this by x, so I guess we have this, so we end up having 3 raised to the power of x all over x, then equals 9. All right, now let us find the inverse or the reciprocal here. We end up having x all over 3x, then equals what? 1 all over what? 9. All right, okay, what I just did now was just to find the reciprocal, just turn it upside down. All right, now let us put the right hand side into a linear kind of, okay, and according to indices, when you have 1 all over x raised to the power of n, this gives you x raised to the power of what? Minus n. Okay, in the same vein, if you have 1 all over x, it's the same thing as saying x raised to the power of what? Minus 1. Okay, I guess I said x raised to the power of minus n. Alright, if you apply that rule here, which implies here that x times 1 all over 3 raised to the power of x equals what? 1 over what? 9, right? So we can also see here that this is x, then times 3 raised to the power of minus x, then equals what? 1 all over what? 9. Alright. Okay, now here is where the journey begins on how to come about this. Alright, so how then do we do this now? Now let us also take note that if we have e raised to the power of ln x, okay, sorry, it's the same thing as saying x. Okay, so when we have x, it's the same thing as saying e raised to the power of ln x. Okay, because the e, Alright, we undo the ln, thereby giving us x. Alright, so now if you apply this rule here down to this, take note our goal is to ensure that we come up with an expression or an argument like this. Okay, so our 3 here now, which is represented as x, now can be in this form, so which implies that we can see x, okay, then e, then ln, okay, then 3 raised to the power of minus x. Alright, sorry, let me make it more clearer. We have x, then e, ln, okay, then 3 raised to the power of minus x, all equals what? 1 all over 9, right? Alright, so now that we have this now you can see it's becoming like this, okay? Alright, now but let us let's come back to logarithm also, the power formula, right? Yeah, so here we are, if we are, let's say log a raised to the power of n, now this will give us n, then log a. Alright, now if you apply this rule to this particular one here, this power here, we get to have x, okay, then e minus x ln 3, then equals to 1 over what? 9. Alright, so I hope you are, now you can see it's looking like this now, right? So the only challenge we have now is we have negative x ln 3 as the exponent here, we have e. Now but here you only having x, right? And what we need to do is to ensure that wherever coefficient of e is must be the same thing as the power of e. Alright, so how then do we get it? Then we can see that the only missing term for x here is just negative ln 3. Okay, so what we just need to do now is to multiply both sides of the equation by negative ln 3. So here we have negative x, then ln 3, then e raised to the power of negative x ln 3, okay, then equals then 1 over 9 open bracket negative ln 3. Okay, now you can see that this particular expression or argument now is the same thing, where our a is negative x ln 3, and our a here also is negative ln 3. I guess we've gotten to that point where we can now apply the Lambert W function. Alright, so we now see into negative x ln 3 e x ln 3, okay, alright, then equals then w, then here we have negative ln 3 all over 9, right? Yeah, because 1 over 9 times negative ln 3 will give us this. Now, and take note by the rule, when W function, the Lambert W function, is applied to an argument like this, then it gives us what? The term. Alright, so here we have, the whole of this now becomes negative x ln 3, right? Then equals w into negative ln 3 all over 9. Okay, now let us divide both sides by negative ln 3, negative ln 3, so negative then ln 3, so our x now becomes into ln 3 all over 9, then all over negative ln 3. Okay, alright, to find the value of this, now take note, our w here, so n takes, our n is -1 or 0. Alright, so by calculator, if I do find the Lambert function of this, now we get to half. So you get your answer to be 3 or 0.127869 continuously. Okay, all right, so this is the application of Lambert W function when it comes to an exponential equation that you cannot solve using the algebraic method. Okay, but logically, if you look at it here, if you take a look at it logically, the answer seems to be, or is rather, 3. That is, if you have 3x then equals 9x. Okay, so if you divide both sides by x, so you get something like this: 3x all over x then equals what? 9. By means of manipulation, we can say that 27 all over 3 is the same thing as 9, right? Okay, let us now replace 9 with 27 all over what? 3. Okay, now let's raise this to the base of 3. So here you have x, 3x all over x, then equals 3 raised to the power of 3 all over 3. Now you can see that there's similarity between these, the left hand side and the right hand side, so you can conclude that x equals what? 3. However, this exponential equation has two solutions, 3 and 0.17869 series of numbers. Alright, if you love what I've just done, kindly subscribe to my YouTube channel and ensure you click on the notification button to be notified of all my videos in physics and mathematics. Thank you. Remain blessed.